All right, team, this is your last AP Calc quiz of semester one. This quiz is on the three derivatives rules we learned this week. So product rule, quotient rule, and chain rule. I've rewritten those rules up top here in the corner. Feel free to use the reference I posted in Google Classroom on this and on the quiz. Just keep in mind that you won't be able to use it in the AP exam. So use it as much as you need to, but use it with the goal of memorizing them in mind. So like the way to do it is think about what the rule is and see if you remember, and then check the formula sheet to check yourself, right? So try to remember it each time, and then with enough practice you'll remember all of them without even having to really work at it. The last thing I'll say before we jump in is if you have not done the Delta Math this week and you're watching this video, the Delta Math this week will definitely help you more on the quiz than this video will. So you cannot do well on the quiz without having done the practice. It is crucial that you just kind of practice these rules first, because this quiz is about applying these rules not just to like functions like this, but also to tables and graphs and all that. So you need to know them reasonably well before you start this. Okay, as always, skip around in the video as you need to. You don't need to watch the whole thing if you don't feel like it's helpful to you. Just use it as a reference as much as you would like to do well in the quiz. Our first problem here is going to be a quotient rule problem, and I know that because there is a fraction bar, so we are dividing. So I'm going to follow my quotient rule, and I guess for this one, for quotient rule, I should write this up means this is for f over g. So f over g prime is equal to all that. Okay. So f is my top function, and then g is my bottom function. So quotient rule for this guy would be x plus 3. Bottom function comes first. That's like hard for folks to memorize. And then the derivative of my top, which is 2x plus 3. I use power rule, right? So x squared is 2x, and then derivative of 3x is just 3, and the derivative of 2 is 0. Okay, so g f prime minus f, which is the top, times g prime, and the derivative of the bottom is just 1, right? So that's convenient for us. And then we should have x plus 3 squared on the bottom according to our model here. Okay, and we should notice that none of our answer choices look like this, I don't think, right? So we'll do a little bit of simplification. You could Punnett square this, right? I think most of y'all do that in your head at this point in your math careers. So 2x squared plus 6x plus 3x is 9x, right? And then plus 9 minus x squared minus 3x minus 2. And then I'm going to notice that my answer choices have x plus 3 in them and leave that alone. Or x plus 3 squared, rather. And I'm going to leave that alone. And I'm just going to combine like terms on top. And done, right? So I get x squared plus 6x plus 7 over x plus 3 squared. So that is f prime of x. And there we go, quotient rule. That is answer choice C. Okay. So this is the easiest one. They get harder from here. Next one is chain rule. Chain rule is the coolest rule. It's my favorite. So chain rule says we take the derivative of the outside function and then times the derivative of the inside function. So I could rewrite this as y equals u squared, and then where u is x to the third plus 1. And then, so the derivative of u squared is 2u. So really that's 2 times x to the third plus 1. And then I want the derivative of u. So I want u prime is 3x squared times 3x squared. So that's 6x squared, and then add plus 1. And that is choice E. Like I said, chain rule is my favorite rule. We're going to be using this one a lot this year. Okay, another chain rule problem. This one's trickier though. So think about why that might be trickier. And the answer is because we're also going to use quotient rule. Okay, so this one, we'll say y is u to the fifth, where u is x plus 1. Okay, so my derivative would be y prime equals, should be 5u to the fourth by power rule times u prime. Okay, so I need to figure out what u prime is. And to do u prime, I'm going to do quotient rule. So quotient rule, I'll rewrite it so you can see it. G times f prime minus f times g prime all over g squared. Right? So the bottom, so u prime, is going to be the bottom times the derivative of the top, so that's x plus 1, times 1, right, because the derivative of x is 1, minus x times 1, because the derivative of the bottom is also 1, all over x plus 1 squared. Okay. So, we need to simplify? I guess we can. This just gives us, our x's cancel out, and we're left with 1 on the top over x plus 1 squared. And then what I get, so y prime, and this by the way is u prime in my notation here, 5 times x over x plus 1 the fourth times 1 over x plus 1 squared. Okay, so this one is tricky. So here's my derivative. I'll draw a box around it to keep it away from my mess over here. This one is tricky because notice none of our answer choices look like this. So you guys are probably able to figure this out. What I need to do is I need to combine these. So really, when I have x to the fourth, or x over x plus 1 to the fourth, I can rewrite that with the exponent just on the top and the bottom, x to the fourth, x plus 1 to the fourth, times 1 over x plus 1 squared. And then what I can do now is add my exponents down here in the bottom. X to the fourth, and then x plus 1 to the, okay. And I guess I can write my 5 up here, right? So we'll say 5x up here. So it looks like our answer choices instead of out front. Okay. So a little bit trickier of a chain rule example. We use the quotient rule as well, and whereas this guy, choice D, is my solution here. Okay. So those are the kind of the easier problems. This last one is a little bit trickier, but these are the ones we're just testing out whether we know the rules or not. The next ones are going to ask us to do some work involving tables or like trickier functions or graphs. So make sure you're really confident in the rules before you tackle these. So f is a differentiable function such that f of 9 is 18 and f prime of 9 is 7. If g is the function defined by g of x equals f of x over root 9, what is the value of g prime of 9? So we're dividing again, so we have a quotient rule. So we want the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. So this guy is going to be f prime of x times the bottom square root of x minus, now this you might be like, this is a rule I don't know, but this is really x to the 1/2, right? So if it's x to the 1/2 power, then the derivative becomes 1/2 x to the negative 1/2. So same rule, I just subtracted 1 and multiplied. So minus, I'll do all of that in parentheses. So 1/2, oops, not negative 1/2, right? So 1/2 x to the negative 1/2 times f of x. And then all over g of x squared. Well, that's kind of nice because g of x squared, root x squared is just x, right? Okay. So This we call g prime because it's the derivative of g. And then we want g prime of 9. So g prime of 9 is equal to, well, f prime of 9 times the square root of 9 minus 1/2 9 to the negative 1/2 times f of 9 all over 9. Okay, now we just simplify. And what do we get here? So f of 9, or f prime of 9 is 7. So 7 times the square root of 9 is 3 minus, this is tricky here, so 1/2, 9 to the negative 1/2. 9 to the negative 1/2 is 1 over 3, right? Because to the 1/2 power would be 3, and then it's negative, so it's underneath the fraction bar. So this becomes 1/2 times 1/3 times f of 9, which is 18. Okay, all over 9. Okay, and we're getting there. So we'll have 21. 1/2 times 1/3 times 18 is going to be 18 over 6, right? Which is going to be 3 over 9. And look at that, it's all coming together. So that becomes 18 over 9, which is a nice result of just plain old 2. A lot of steps, but still the same rules, right? So A is our solution there. Okay, this one is just a plain old quotient rule. The reason I put this one on here is because of the notation. This is not the notation that I usually use, so I want you guys to see it so you're familiar with it. So this just means take the derivative of that. This one's easier. So I want the bottom, x squared plus 1 times the derivative of the top, but the derivative of the top is just 1, this is 1x, right? Minus the top times the derivative of the bottom, so that's x plus 1 times 2x is the derivative of the bottom, all over x squared plus 1 squared. Okay. So I'm going to rewrite that just a little bit to make my distribution easier first. There's a number of ways you can simplify this though. So 2x, x plus 1, and my way is not necessarily the best way. And then I'm going to distribute, so I get x squared plus 1 minus 2x squared minus 2x all over x squared plus 1 squared. And notice this shows up in a lot of my answer choices, so I'm not going to mess with that if I don't have to. I'm just going to combine like terms on top and cross my fingers. So on top, I'm going to get negative x squared minus 2x plus 1, and then x squared plus 1 squared. And that is choice B, so we're good to go. So this d dx means take the derivative of whatever's inside. So there's no like chain rule or involved or anything weird here, just a plain old take the derivative problem. Okay, now we got a couple of fun ones coming up. So the function f is defined by f of x equals blah blah blah, and you should look at blah 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 in this case and think quotient rule, right? And then what points x, y in the graph have the property that the line tangent to f at xy has slope 1/2. Oops. So we're going to take the derivative here, and we're going to use quotient rule. So that is going to be x plus 2 times the derivative of the top, which is just 1, minus the derivative of the bottom times the top, which is just minus x, right? And then over the bottom squared. I'm going to call that f prime of x. All right, the derivative of f. And then I'm going to simplify, and my x's cancel out on top, right? So I'm left with 2 over x plus 2 squared. And then the tangent line has a slope 1/2. So most important calculus fact is the tangent line, the slope of the tangent line is the derivative, right? where the derivative is the slope of the tangent line, so set them equal to each other. There's a couple different ways I can tackle this. Here, I can cross multiply, right? And I can get 4 is equal to x plus 2 squared. And then I'm going to square root both sides. And make sure when you take the square root, we want a plus minus. So I'm going to get plus minus 2 equals x plus 2. Plus minus 2 equals x plus 2. And then I can split this up into two equations. And that's how I'm going to get my 2 points. So notice it's going to be one of these guys with two solutions there. So I'm going to say x plus 2 equals 2. X plus 2 equals negative 2. And I get x equals 0. X equals negative 4. Okay. So that leads me to pick C. Notice if you gotten your signs wrong, you would have picked D and you would have gotten it wrong. And I don't really need to check the Y's because there's no choice that is like 0, negative 4 for my X's and then different Y's. If there were, I would want to check the Y's to distinguish between the two. Okay, so the derivative is the slope of the tangent line. That's a key fact in this problem, and that's going to show up on your quiz as well. Okay, just got a couple more. This number 16 is the spiciest one, I think. So a particle moves along the x-axis with its position at time t given by blah, 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 but blah, blah, blah has a's and b's in it. But a and b are constants, so that means they're just numbers, and a is not equal to b. For which values of t is the particle at rest? So, well, at rest means that velocity is equal to 0 at that t, and we have position, okay? So we want to take the derivative of this function. We want x prime to be equal to 0, because x prime is velocity. Okay, so this a and b kind of makes things trickier. But I'm multiplying. So I'm still going to use product rule. I'm going to say derivative of my first thing times the second thing plus the derivative of the second thing times my first thing, right? So x prime of t is going to be, the derivative of my first thing is just 1, right? So t minus b is my second thing. And then the derivative of my second thing is just 1. So t minus a is my first thing. Okay? So that's product rule. So by product rule, I get that the velocity function is equal to t minus b plus t minus a. I could also expand this using a Punnett square and take the derivative that way, and I would get the same result. So here, I want to combine like terms, and I have just 2 t's minus b minus a is equal to 0, right? And then I have to isolate t because all my solutions have t isolated. This actually becomes kind of like an SAT problem that you guys were probably good at. So I'm going to add b and add a to both sides, and I get a plus b equals 2t, and then a plus b over 2 equals t. So that's pretty cool. So I don't even need numbers in this problem to solve it, right? This tells me that for any a and b that have the property that add them together and divide them by 2 is equal to the time, the particle will be at rest. Okay. I believe we just have 2 more. Slope of the tangent line where x equals 1 to the graph of y equals blah, blah, blah. And then we have a quotient rule problem again. A lot of quotient rules in this one. What would be the bottom, x squared plus 1 times the derivative of the top, and the derivative of the top here is 2x, right? Minus the derivative of the bottom, which is also 2x times the top, x squared minus 2. And then all over x squared plus 1 squared. Okay, and that's going to be, I'm going to call that y prime because it's the derivative of y. And then I'm going to simplify some. So 2x to the third plus 2x minus 2x to the third plus 4x on top. And then bottom I'm just going to leave alone because I'm just plugging 1, 2, into it. Expanding it's not going to help me that much. And then I could actually just plug in 1 to what I got up here, but I think it's actually easier to do a little bit of simplifying first before we plug anything in. So these guys cancel out. I get 6x over x squared plus 1 over, or squared rather, y prime. And then I want to take y prime of 1. So I can rewrite that like this, y prime of 1. That's good notation here. Is 6 times 1 over 1 squared plus 1 squared. So that's going to be 6 over 4. 1 plus 1 is 2. Squared is 4. So 6 over 4, let's find it in our answer choices. So that reduces, of course, to 3 over 2. Is the slope of the tangent line. And if this problem asks for the equation of the tangent line, I plug x into my function to get my y, and then plug that point into my y equals mx plus b, or point slope form if you know it. Okay, so that is it, you guys. I hope this is a useful reference to you. As always, remember you can go back and rewatch any problems that you need as many times that you need in order to do well on the quiz. So the quiz is about chain rule, product rule, and quotient rule. And graphs, tables, or functions, or word problems, all fair game. I think you guys are going to do quite well as long as you've been keeping up with your Delta Math. Good luck, and as always, let me know if you have any questions.